Okay, so here's the section on optimization, and I'm just going to kind of tell you what an optimization problem kind of looks like, and the steps to sort of approach it. So optimization problems are a very common type of real world problem. Oftentimes you're looking for ways to sort of take whatever constraints you have and optimize it. And so you're looking for ways to take one constraint and utilize it as much as possible. Examples could be if you're working on some form of a supply chain and you want to know how much throughput you can take for your supply chain to take a certain good to a certain location. That could optimize it according to how many trucks you have, how many boats you have. You always have to kind of look for potential bottlenecks somewhere. And bottlenecks would mainly be like, oh, maybe I don't have enough trucks to offload a boat each time a boat comes in. So a boat would be sitting there waiting to unload stuff. And so situations like that could occur where you're trying to look at a particular model that you've been given and trying to optimize the best way to move things from one point to another or to produce things. Another way that you can look at it is if you're trying to optimize some variable, which is in terms of another one, and trying to use calculus specifically to optimize a maximum or a minimum of your usage or throughput of that variable according to what your model says. And so the optimization is a very real world application of calculus, and it's a very common way for you to kind of be looking at situations and trying to figure out the best way forward using it. And so let's go over the procedure for a optimization problem. So the first step is to identify what variables you have. So trying to figure out how much of something there could be in a potential case, or trying to figure out how fast something moves or how fast you can change one resource into another. That's all part of the identifying variables kind of process. You then try to construct relationships between the variables. So finding equations which could relate different variables to each other or relate different constraints to each other. And you would then try to simplify all of that into one function, one f of x, to allow you to sort of operate or find the optimal way of operating your business or your situation, your optimization problem with regards to that function. This then allows you to do step 2, which is finding the critical numbers of your f of x function. If you're able to find the critical numbers of your f of x function, then you should be able to find the absolute extrema of your f of x. And so you can find either the maximum or the minimum on a particular domain that you're looking at. And then you would answer the question with the solution to the model. And so whatever solution you get from your model of what x is going to give you the extrema for that particular function is how you would go back through the process and back through the relationships that you found to answer some of the constraints that you need to put or some of the constraints that you need to change in order to get the most optimal result from your particular optimization problem. And so you would go through it and you would say, okay, well, this is what my maximum or my minimum from my analysis says we need for this particular variable. So let's find all of the other variables which were related to it to set up our system for to be optimal. And that's the process that you would go through for an optimization problem. There are a lot of them out there, so it's always kind of good to know how to do it and how calculus applies to optimization problems because it can both help you find the most optimal solution, as well as be a helpful guide to analyzing the situation and potentially looking for ways that you could change it to increase the output. So that's all I have for this section. I hope it was informative, and I'll see you guys for the next one.